Hi everyone, welcome back. Good morning to all of you. Today we're going to talk about one of the important class of battery that is comes under modern battery. The last couple of classes I was focusing about construction, working and applications of various class of primary and secondary battery. We all know that primary battery is nothing but a kind of irreversible battery, which means we can't able to recharge the battery or we can't able to reverse the cell reactions. That class of battery is called as primary battery. The secondary battery is nothing but where the cell reaction can be reversed. For an example, if you are connecting the battery with an external load, the discharging process will take place, and if the battery is connected with the external source of EMF, then current will be allowed to enter into the battery compartment. As a result, at the expense of electricity, we are going to reverse the chemical reaction. So such class of battery is called as secondary battery. Now I am going to talk about one of the important class of modern battery. In the last class I focused about another important class of modern battery that's going to be that was lithium battery, and today I am going to focus about zinc air battery. Alright, now what are the materials we are in need to construct the zinc air battery? So if you want to construct a zinc air battery, we are in need of the following materials: the anode, zinc container as well zinc powder, and cathode will be a air cathode will be utilized over here, and electrolyte is going to be a 6 molar KOH solution. What is the function and how it can be constructed? So this is a typical schematic representation of zinc air battery. You may evidence this kind of battery earlier. This is a kind of button based battery where cathode compartment, anode compartment and a separator and zinc powder is allowed to feed in over here, and also there are two air vents available to capture the atmosphere oxygen. Now this is the schematic representation. Now what is the mechanism and what is the operating principle of this zinc air battery? So basically, when the zinc air battery, once the completion process gets completed, once the construction process gets completed, now the zinc air battery is connected with external load. Now what are the kind of chemical reactions will be taking place inside of the zinc air battery? So basically, we all know that it will have it's a kind of container. So this is the cathode container, and wherein anode container also available over here, and there are two air vent also available over here, and in which zinc powder plus 6 molar KOH is also placed, and the anode and cathode is separated with the help of a kind of insulating material, polymer based insulating material. And once the battery is connected to the external load, now atmosphere oxygen is allowed to enter into it. Now oxygen molecule will enter into the battery compartment. Now once the oxygen is entering into the KOH solution, so it will go and accelerate or it will activate the KOH, that is potassium hydroxide. It will be used as an electrolyte. So KOH gets activated. Now once KOH gets activated, it will force the oxygen molecule to undergo reduction at the cathodic compartment. See, once the battery is connected with external load, now as usual oxidation and reduction reaction will be taking place. So it's a kind of galvanic cell based battery. We all know that in all the type of galvanic cell type based batteries, there are two processes which is responsible for the production of EMF, and one is going to be due to the decrease in the free energy of the system leading to the production of EMF. So whenever any chemical reaction will be taking place, there are three type of all the three type of thermodynamic parameter will get changed, which they are called as like Gibbs free energy and enthalpy of the particular reaction and entropy of the system. All will get changed, and there is a decrease in the free energy of the system leading to the production of EMF, whereas N is nothing but number of electron transferred from anode to cathode compartment, and F is nothing but Faraday, and 1 Faraday is equal to 96,500 coulomb, and 500 coulomb, and E is nothing but quantum of output produced by the particular cell. And the second one is going to be due to redox reactions. Now we all know that what is the redox reaction. So basically redox reaction is nothing but a combination of both oxidation and reduction occurs simultaneously. Oxidation is nothing but removal of electron. Whenever any valence electron is removed from the metal compartment, that is called oxidation. Removal of electron is called oxidation, and addition of electron, or we can call it as gain of electron. Gain of electron is called as reduction process. As a result, the metal ion gets reduced over here. Okay, the combination of these two processes is called as redox reaction. And both these processes are highly responsible for the production of EMF, that is decrease in the free energy of the system and redox reaction. So, in the case of modern battery also, there will be a similar type of reaction will be taking place. One is the electricity is produced due to the expense of or due to the decrease in the free energy of the system, as well due to redox reactions. So, both are responsible for the production of EMF. Now, we are going to connect this battery with external load. Now, as usual, at anode oxidation reaction will be start to occurs. Now, this is called anode compartment, where it's made up of a kind of zinc material, and this is called cathode material. This cathode area, cathode cap. This is called anode cap. Now, the anode, unlike other battery, here the anode materials do not undergo any type of oxidation process, whereas the zinc powder, which is available with the 6 molar KOH, will try to undergo oxidation process. As a result, zinc will be converted into Zn2 plus, and it will use to release 2 number of electrons. Once zinc ion is liberated, so it will try to combine with the KOH, that is hydroxide anion, OH minus. So, 2 hydroxide anion will be utilized, and subsequently it used to produce zinc hydroxide. So, 1 mole of zinc hydroxide will be produced over here, and when you look at the thermodynamic stability of the zinc hydroxide, it seems to be a very less. As a result, zinc hydroxide will undergo modification or the further chemical reaction, and it used to produce zinc oxide. Zn will be produced. So, due to the formation of the zinc oxide, this off cell can able to produce the maximum output of is equal to 1.20 voltage. Okay, so this is the oxidation reaction. Simultaneously, reduction reaction will also be carried out at the cathode. So, at cathode compartment, so there will be a reduction reaction will be taking place. Now, air molecule which is trapped during the process will undergo reduction process. So, in the case of other secondary batteries or other primary battery, cathode material itself will undergo oxidation process, but in the case of modern battery, such kind of chemical reaction will not be taking place. Here, the oxygen molecule which is absorbed during the process will undergo oxidation process due to the consumption of electron which is released from the anode area. So, now the oxygen molecule is get reduced and it will be converted into corresponding hydroxide radical. Now, due to the formation of this hydroxide radical, it can able to produce the output of 0.45 volt. Now, the combination of these two reactions is called as redox reaction, which means zinc plus half mole of O2 plus H2O. It gives Zn oxide plus zinc oxide plus 2 moles of hydroxide anion. So, due to this redox reaction, it will release considerable amount of electricity as output, and it corresponds to 1.65 voltage. So, a zinc cell can able to produce to the maximum extent of 1.6 voltage output. So, here when I look at the lifetime of this battery, why we need to go for this kind of modern battery? Because when you look at the other battery devices, many other battery do not meet our requirements. For an example, many battery fail to meet our requirements such as durability, lifetime and active nature of the cathode and anode area. Here in the case of zinc battery, we are not going to consume or we are going to utilize the cathode compartment as such, because the cathode compartment is utilized only to get the charge from the corresponding battery. We are not going to force the cathode area to undergo reduction reaction, whereas here the reduction reaction is taking place only in the air cathode. So, here air itself, that is the oxygen which is available in the air itself will act as a cathode. So, that cathode area itself undergo oxidation reduction process in fact, and it used to produce 2 moles of hydroxide anion. So, the lifetime of the battery seem to be very high when compared to the other type of battery. Now, what are the advantage and disadvantage of this battery? So, basically as we discussed earlier, when you look at the advantage of this modern battery, or else we call it as zinc battery. It is highly superior than other primary battery. In fact, it's a kind of primary battery. Here the cell reaction cannot be reversed because it is very difficult to reverse the cell reactions, because we are utilizing the oxygen molecule as the cathode compartment. But here the lifetime will be seem to be very high, because we are not going to use the cathode area as we are not going to consume the cathode area for the reduction process, whereas we are using our anode itself a cathode compartment. So therefore the lifetime will be more. And also the output, when you look at the output, when you look at dry cells, it can able to produce the output to the maximum extent of 1.5 volt, but here it can able to produce to the maximum extent of 1.65 volt continuously. This is another important parameter. And the durability also very high, and it's also occupy very small space, so therefore it can be transported to any place. And there is no leakage for the chance of an electrolyte, because we are using a paste of zinc and potassium hydroxide and electrolyte. We are not using a kind of liquid electrolyte, so you are using almost a semi-solid based electrolyte, so there is no chance for the leakage of an electrolyte. So these all are the advantages of this battery. And when you look at the application of this battery, it is highly found useful in all the electronic gadgets like watches, calculators, and other many electronic gadgets. So these all are the advantage, merits and demerits of this battery. And when you want to prepare such kind of modern battery with reversible characteristics, you can go for zinc fuel cell. So the zinc fuel cell will be act as a kind of reversible cell whose electrode potential is much more higher, and also the reversibility of the cell reaction is very easy, because we are not going to use the cathode and anode area for the oxidation reduction process respectively. Instead, we are going to utilize the fuel and oxidant as the oxidizer and reducers, so which are able to produce the electricity to the maximum extent of more than 2 voltage. So that's all about the information about modern battery, or we can call it as zinc battery. Thank you very much.